Okay, students, so I am recording this special tutorial video to learn about this digital multimeter. Okay, so most of you, this app lab is the digital multimeter which has been sent to you. Maybe for some of you, you know, a different model or different from a different manufacturing company. This has been sent to you, but in that still in that case, you know, the functions will be very similar to what we are going to learn with this particular model. Okay, so what you see here is this you know, semicircular knob with the various things written at various positions. So right now this is pointing towards the off, and then this is with the blue color, that is AC voltage, and then this particular position is to measure the, you know, resistance, check the continuity, or check the diode. Then it's a capacitor, frequency. I think all these things you will not be needing. This is the, you know, HFE is basically the gain of transistor, and then these three is for the currents. Okay, depending if the current is microampere, milliampere, and ampere. Okay, and this is for your AC current as well as the DC current. So you see this is straight line as well as this sinusoidal signal. Okay, so now to check that, I have also kept a, you know, DC power supply over here through which we will be measuring voltage and current. Okay, so these are the connectors given to you with two different colors, red and black. So black basically is the common and which will go to the common. The red basically is for the signal, and if you want to measure the voltage, resistance, and frequency and capacitance, this red one will go in this port. If you want to measure the current, it will go in one of these two ports. If the current is in microampere or milliampere range, it will go over here, and the current is in amperes range, it will go over here. So right now let's put this to this socket, and then you have these two you know, probes through which you can measure whatever is connected between these 2 points. So the first thing is to check the continuity, whether your multimeter is working or not. So you go to this resistance thing, and if you you know, short them together, the resistance comes to 0 volt, and that indicates that of course the it's shorted. Okay, now if you want to measure some resistance, I have connected a 1 kilo ohm resistance in this breadboard. And if I, you know, if I connect this multimeter between these 2 points, what you read here is 0.995 kilo. That means close to 1 kilo. Okay, that is the value of this resistor. That's very poor practice of, you know, holding a resistance in the hand and then you know, connecting it between the 2 points. Never do that. Actually, what you are doing in this case, you are measuring the parallel of your body and your this particular resistance. And since this resistance is very large, you don't see a big difference. But if you use a very small resistance, then basically what you will see is a very different value compared to the value of the resistor. Okay, so always put whatever you want to measure in a breadboard given to you, and then using these probes you connect the 2 points. Okay, now I'm going to switch on this power supply, DC power supply, or basically you can do it with this 9 volt DC battery. Okay, but this will draw very less current, and that's what I'm trying to show your voltage and current measurement with this DC power supply. Okay, so this is the output port. Right now it shows the voltage over here. I can go to the voltage setting, okay, and try to measure the voltage simply by connecting it to this output thing, and this tells me the voltage of 20.08 volts. Okay, by mistake, if you change the polarity of your positive probe and the negative probe, you will read the voltage as negative volts, because now I have changed the polarity of the multimeter. So if the voltage shown to you is negative than what you are expecting, that means you have connected the probes in opposite polarity. So, you know, make necessary corrections for that. Okay. Otherwise, it's always a good practice that we, you know, connect a connector from this power supply, and we, you know, connect these connectors in a, you know, breadboard, and then make the voltage measurements. Okay, so this is for the voltage measurement, resistance measurement. Now let's learn this current measurement. So the current normally drawn will be very large, because if you simply short circuit these 2 points, it will try to draw the maximum current from this power supply. So that's why I'm going to add a small resistance between the two. So positive comes here. So I'm just going to make a series connection to measure the current. So what I've connected is the positive from the power supply goes to one end of the resistor, and the other end of the resistor, basically I'll connect a multimeter in series, and then other end of the multimeter will go to the negative of the power supply. Okay, and this is a 1 kilo ohm resistance, and appropriately I change the current to this milliampere range, and I go to the milliampere settings for this thing. Now I switch on the power supply. So this 20 volts divided by, you know, 1 kilo ohm is 20 milliampere, and that's what you see over here. Okay, and you can also see the current reading from the power supply. It shows 0.02 ampere. That means 20 milliampere, and the same thing also you read in the multimeter. Okay, if you decrease the voltage by a factor of 2, that means 10 volts, your current becomes 10 milliampere. Okay, so that's how you do the current measurements. You need to see for voltage there is only one position, depending it's a millivolt or volts or, you know, hundreds of volts. But for current, depending on the internal resistance used, you have these three settings. So depending on the resistance used in a given circuit, you should know beforehand that how much current you are expecting in your circuit, and then appropriately use that position for this knob, and then also apply this connector to that particular slot, and then measure the current. And in that case, your multimeter should be in series, not in parallel. For all other measurements, your multimeter will be in parallel. Okay, so this basically is for the voltage, current, and resistance measurement. You can measure the, you know, capacitors, but right now I don't have that connector. But in that connector, if you insert the capacitor, basically it will go between these 2 points. So you add that connector which is given to you, and insert the capacitor, and rotate the knob to this particular position, so that you will directly be reading the capacitance of the capacitor. Okay, all other things are not needed. So yeah, I think that's it for the multimeter.